Okay, so imagine you're like me, and you're trying to stay on top of all the latest AI stuff. But then, you get hit with this mountain of research papers. It's a lot to keep up with. But that's kind of what we do here. So today we're going to do a deep dive into one that really caught my eye. It's about AI tackling these really complicated tasks. And you won't believe this. We're talking about AI tidying up a house.
Yeah, that's right.
Yeah.
This paper from researchers at the Allen Institute for AI, it just came out this year, and it really dives into all the nitty-gritty of something they call large-scale task planning in partially observable environments. Kind of a mouthful, right?
Yeah, but it sounds kind of cool too. So wait, are we talking like AI doing chores here? Because sign me up for that.
Well, not quite in the way you might be thinking. We're not talking about robots with feather dusters just yet. But the idea is to see if AI can figure out how to plan and execute these complex tasks, the kind of things we do around the house without even really thinking about it.
Okay, so how does that even work? How do you teach an AI to tidy up?
Well, they use a really clever combination of two powerful AI tools. First, you've got large language models, or LLMs. You might know these as those supercharged chatbots everyone's talking about.
Right, right. Those things can write you a poem or summarize a whole book for you.
Exactly. But the researchers here use them in a totally different way. And then they combined LLMs with something called Monte Carlo Tree Search, or MCTS for short.
Okay, I've heard of the chat box, but MCTS, what's that all about?
It's a method that lets the AI explore all sorts of possibilities and then make decisions based on what it learns. So instead of just spitting out actions randomly, it's like the AI is thinking strategically.
Interesting. But I'm still a little fuzzy on how these chatbots play into all of this. It's not like they could physically move things around, right?
You're right, and that's where it gets really interesting. They didn't use LLMs to control a robot arm or anything like that. Instead, they used LLMs to create what they call a common sense world model for the AI.
A common sense world model. What does that even mean?
It means the AI is learning how the world works. We all have this basic understanding of where things are likely to be found, right? If you're looking for a coffee mug, you're probably going to check the kitchen cupboard before you look in the bathroom.
Yeah, that makes sense.
Well, the researchers used LLMs to give the AI that same kind of common sense, so it can predict where things are likely to be based on what it knows about the world.
Okay, so the AI is like building a mental map of its surroundings.
Exactly.
But hold on. Real life is messy. What if the mug isn't in the cupboard?
That's where the partially observable part comes in. The AI doesn't have perfect information about everything in the environment.
So how does it deal with that? Does it just give up?
Not at all. It uses probabilities. It might say, okay, there's a 70% chance the mug is in the cupboard, a 20% chance it's on the counter, and a 10% chance it's, who knows, maybe the dog took it.
Okay, so it's making educated guesses.
Precisely. And that's where that MCTS thing comes in. The AI runs simulations of all these different possibilities to try and figure out the best course of action.
So even though it doesn't know for sure where the mug is, it can still make a plan based on what's most likely.
Exactly. It's kind of like how we make decisions in real life.
This is really cool.
Yeah.
But it also makes me wonder, how does the AI actually decide what to do? Does it just randomly choose actions based on those probabilities?
That's a great question. And the answer is no. They actually use LLMs in a second way here as what they call a heuristic policy.
A heuristic policy. What's that?
Think of it like a set of guidelines or rules of thumb that help the AI make smart decisions.
Okay, so it's like giving the AI some extra help in figuring out what to do.
Right. It's like having a friend who's really good at tidying up, giving you hints.
I could use one of those.
Well, maybe someday soon you will.
So where do these guidelines come from?
They train the AI on a data set of expert actions. So it's actually learning from humans who are good at tidying up.
So it's like the AI is watching a bunch of cleaning videos and taking notes.
In a way, yes.
That's amazing. So I'm starting to get how all these pieces fit together. But how did they actually test if this AI could really tidy up? Did they let it loose in someone's house?
Not quite. They needed a way to test this in a really realistic but controlled setting. So they used what's called a simulation, specifically one called Virtual Home.
Virtual Home.
Yeah, it's like a super advanced version of The Sims. But for AI research...
So like a virtual dollhouse for robots?
Basically. It has hundreds of objects, multiple rooms, all sorts of complexities that make it a really challenging environment for the AI to navigate.
So they basically built a digital playground for the AI to practice its tidying skills.
Exactly.
I love it. So the big question is, did it work?
The results are actually pretty impressive. They gave the AI a whole bunch of tasks, including some it had never seen before, And this LLM-MCTS approach outperformed all the other methods they tested.
So it actually worked.
It did.
Yeah.
And what's really interesting is that it was especially successful on those novel tasks, the ones it had never encountered before.
Oh, wow. So that means it's not just memorizing a set of instructions. It's actually learning how to generalize its knowledge and adapt to new situations.
Precisely.
So wait, are you telling me this AI could tidy up a house it had never even seen before?
That's the idea.
That's incredible.
And there's more. It could even handle tasks with multiple objectives, like putting away groceries and then setting the table.
Wow. So it's not just doing one thing at a time. It's planning out a whole sequence of actions.
Right. It has to remember multiple goals, figure out the most efficient way to accomplish them all.
That's amazing. It's almost like this AI is thinking for itself.
It's definitely a big step in that direction.
I'm blown away. But you know what I'm really curious about now? Why did this approach work so well? Like, what's going on under the hood that makes this so effective?
Well, that's where things get even more interesting. The researchers didn't just stop at showing that it works. They wanted to understand why. And that led them to this really fascinating question. When is it better to use LLMs as a model of the world versus using them as a policy for taking actions?
Whoa. Okay, that sounds pretty deep. But it also sounds like a question for part 2.
You got it?
I can't wait.
We'll dive into that next time.
See you then. Okay, so we're back, and last time we were like right on the edge of figuring out why this whole LLM-MCTS thing works so well for AI tidying.
Right. It's one thing to build something that works, but understanding the underlying principles, that's what takes us from like a cool hack to our real breakthrough.
Totally. So remind me again, what was that principle they used to analyze all this?
It's called the minimum description length principle, or MDL for short.
MDL. Okay, I feel like I'm back in school here.
Don't worry, it's actually a pretty simple idea once you wrap your head around it.
All right, I'm all ears.
Basically, it says that the best explanation for something is usually the simplest one.
That makes sense. It's like Occam's razor, right? The simplest explanation is usually the best.
You got it.
So how does this apply to our AI tidying expert?
Well, remember how they used LLMs in 2 ways?
Yeah, as a model of the world to predict where things are, and as a policy to guide the AI's actions.
Right, so it's like having a mental map of the house and a set of tidying tips all in one.
Exactly.
Now the MDL principle comes in when we're trying to decide which of those is more efficient for a given task.
Okay, I see. So sometimes a detailed model is super important, like if you need to find a specific item. But other times, a simple policy is enough, like if you're just putting away a bunch of similar objects.
Exactly. It's about choosing the right tool for the job.
Okay, that makes sense. But how do you actually measure this description length thing?
It gets a little technical, but essentially you're comparing how much information is needed to represent the model versus the policy. The one with the shorter description is usually going to be more efficient.
Okay, I'm going to trust you on the technical details there. Yeah. But I'm curious, did they test this out on anything besides just tidying up? It seems like a pretty universal idea.
You're right. It's not just about tidying. They actually applied MDL to things like multiplying large numbers.
Real?
Yeah, and planning travel routes.
Wow. So it's not just for robots.
Nope, it's a much broader principle.
That's fascinating.
And what's really cool is that their predictions based on MDL actually matched up with the results.
So this isn't just some abstract theory. It has real-world implications.
Absolutely.
It's making me see those LLMs in a whole new light. They're not just text generators anymore. They're like tools for understanding how we think and make decisions.
That's a great way to put it.
But let's bring it back to those robots for a second. Even with this breakthrough, they're still stuck in the virtual world.
Right.
What are some of the challenges of getting this to work in our, messy real-world homes?
Well, for one thing, our houses aren't perfectly organized simulations, right? They don't come with a handy list of every object in its exact location.
Exactly. And I can barely keep track of everything in my own apartment, let alone expect a robot to do it.
You've hit on a key challenge there, perception. In Virtual Home, the AI has perfect information about every object. But real robots have to rely on sensors, which can be fooled by lighting shadows, clutter all the things we humans love to surround ourselves with.
Right. It's like the difference between following a map and trying to navigate a jungle blindfolded.
Exactly.
And even if the robot could see perfectly, grabbing and moving objects in the real world is a whole other level of complexity.
Absolutely. Manipulation is a huge hurdle. Robots need the dexterity to handle all sorts of shapes, sizes, and even delicate objects. We're a long way from robotic hands that can rival human skill.
Yeah, and let's not forget about the safety aspect. A clumsy robot let loose in my apartment sounds like a recipe for disaster.
For sure, safety is paramount. A real-world AI would need to not only navigate physical obstacles, but also understand human behavior, social norms, safety protocol. It's just a lot to ask.
So maybe a robot butler is still a few years off.
Maybe.
But this research definitely feels like a major step forward.
It is.
It's making me think about all the amazing things we could achieve if we could get these robots out of the virtual world and into our lives.
That's the dream, right?
It is.
And it's a dream that might be closer than we think.
Well, this has been an incredible journey so far. We've gone from AI tidying up a virtual house to exploring the very real challenges of bringing those skills into our actual homes.
It's been quite a ride.
It has. But we're not done yet. In our final part, we'll explore the potential real-world applications of this research and all the exciting possibilities that lie ahead.
I can't wait.
See you then. All right, so we're back for the final part of our deep dive. And we've come a long way, from AI tidying up in a virtual world to all the real-world challenges of actually bringing those skills into our homes.
Yeah, it's been quite a journey.
It has. But now it's time to get to the fun part. What's all this actually going to lead to? What are the possibilities?
Well, there are a lot of potential applications that have me really excited.
Okay, like what? Give me the good stuff.
Well, one area that I think has immense potential is assistive robotics. Imagine a world where robots can help people who need assistance with daily tasks, like older adults or people with disabilities.
Right, so we're talking about robots that could help with things like cooking, cleaning, getting dressed.
Exactly. All those things that can make a huge difference in someone's quality of life and independence.
That's amazing. It's not just about convenience. It's about, empowering people.
Absolutely.
And it's not just limited to helping people in their homes, right?
Right. Think about disaster relief. Robots with this kind of AI could be incredibly valuable in situations that are dangerous for humans, like searching for survivors in a collapsed building or clearing debris after a natural disaster.
Wow, yeah, that makes a lot of sense.
They could even be used to deliver supplies to people in need.
That's incredible. So we've got robots helping people in their homes, robots assisting with disaster relief. What else?
Well, let's not forget about all those everyday chores that we all face.
You mean like laundry?
Exactly. Or maybe even organizing that junk drawer we all have.
Okay, now you're talking.
Right. Even if it's just freeing up some time and mental energy, that's a huge win.
I'm sold. But we have to talk about the other side of this too. Are there downsides to a future with these super capable robots?
That's a really important question. And the answer is yes, there are potential downsides we need to be mindful of.
Okay, like what?
Well, for one thing, there are economic considerations. As robots get better at doing jobs that humans currently do, there's a risk of job displacement.
Right. That's a valid concern.
Yeah.
We need to make sure that the benefits of this technology are shared fairly and that we're creating new opportunities for people whose jobs might be impacted.
Absolutely. And we also need to be really careful about how we design and train these AI systems.
What do you mean?
Well, if the training data is biased, the robots could end up perpetuating those biases in their actions, which could have really serious consequences.
Right. So transparency and accountability in AI development are crucial.
Exactly.
And then there's the question of autonomy. How much decision-making power do we want to give these robots?
Right. That's a big one. Do we want them to be able to learn and adapt on their own? Or should there always be a human in the loop?
It's a tough balance. We want them to be helpful and efficient, but we also need to make sure that humans are ultimately in control.
Exactly.
Well, this has been an incredible journey. We've gone from AI tidying up a virtual house to imagining a future where robots are a part of our everyday lives.
And we've only just scratched the surface.
I know, it's mind-blowing. So what's the big takeaway here?
I think the biggest takeaway is that this technology has the potential to change our world in profound ways, but it's up to us to guide its development and make sure it aligns with our values.
Well said. Thanks for joining us on this deep dive, everyone. We hope you learned something new and had some fun along the way. And until next time, keep exploring,